Hello and welcome to today's video. On the workbench today we've got the AMC325 serial number 1493. If you watched the previous video, I replaced the 16 MOSFETs on the middle power phase, both the high and the low side. I also replaced the capacitor. I got one right here. It blew out the side and welded one of its bolts in it, so I got a new one in there. I also went ahead and did some silicone adhesive. I didn't do the greatest job, but it'll get the job done. So that's all curing. Put the rest of the motor controller back together and replace the fuse, which you can kind of see down there. Go ahead and show that. You can trust me that it's a new fuse, but just in case, you can see it's good now. So we got a new fuse in there, and next is the gate driver. When this guy failed, it shorted 156 volts through the gate driver. Actually popped all of the gate drive resistors, well, most of them anyway. Pretty much any MOSFET that died when it died shorted, it killed the gate. It shorted the gate to 156 volts, which then propagated to here. And it popped, the output of this was shorted, and that was because this P-channel MOSFET has decided to, it died. Took one for the team, and it died shorted. If I go ahead and I can show you this, maybe. Yeah, see. So it's shorted. It doesn't matter which pins. It's shorted, gate to drain, drain the source, source to gate, everything's completely shorted on it. Went ahead and pulled it out. It looks like the high voltage came in through the gate drive connector and went through this guy and then arced directly back to the board. So I don't think it propagated very far. It just kind of went in through here and short. You can kind of see the board here is a little burned where a lot of current flowed through it. However, it did also kill one of the diodes, one of the Zener diodes on here. I guess I can show you that here. This guy, this is a 20 volt Zener diode, and it's shorted out, so I'm going to have to pull him out before I can really check everything, because that actually is the main power supply protection, and it's shorted out. So we'll go ahead and pull that guy out before we can really do anything more troubleshooting on it. You don't want to power these up because, you know, it definitely got exposed to high voltage. We know parts of it are blown up. If you're not familiar, this is the gate driver on the AMC drives. So you end up with gate, source, and drain. Actually, this is drain. That's a no connect. So gate, source, drain on either side there. So the little normally it looks like this, right? It's got this cable on it. Communication and power comes through this, goes in through that cable, which is this connector. It goes to the primary side of the transformer here. This little orange guy is a transformer that has two secondaries and one primary. Each secondary goes to one half of the board and the other half of the board. Just this section is not identical. Everything else is 100% identical, just mirrored, just flipped. So you can actually install this. Well, it can really only go in one way with the connector in the middle, but these are both symmetrical. There's no difference between the high side and the low side of the gate driver. And the secondary comes out of that transformer. It goes through these four Schottky diodes. So there's three up there and one down here, whereas this middle one's the Zener that protects the supply. There's some more Zeners over here. It actually generates, the output is I think around 17 volts positive and like negative 8 or 9 volts, which is used by these two transistors this is a NPN and a PNP transistor, which switch the N and P channel MOSFETs, which then go and switch the 8 big power MOSFETs for the high side and the low side. So one side does the high side, the other one's the low side, and they go out through those connectors. To tell it whether it needs to turn on or off, coming in through here also goes over this opto-isolator, and the output of that is what drives those transistors. It actually does go through some, this is a hex inverter chip. It's a 7414, and the hex inverters in here are used pretty much for time delay, so that prevents cross conduction between these guys, which prevents cross conduction between these guys, which prevents cross conduction between those guys. So yeah, that's pretty much. There's some capacitors and these are resistor packs. They end up developing that. There's also essentially a saturation detect, which comes in on the drain pin here, and that goes through some parts over here to go figure out whether or not the MOSFETs are already conducting, and if they are, then that overrides these guys so it doesn't try to turn on the other side. And yeah, other than that, these caps are your main power supply caps for the 9 volts and 17 volts. Yeah, I don't think there's anything else on there. The rest is just filtering and timing. Yeah, it's pretty simple. So yeah, like I said, this Zener is dead. I'll go ahead and unsolder it, pop him out, and then test everything. Luckily, we've got a completely good working one, and we can compare values from the meter between the two and be able to make sure that everything is as good as it possibly can be. And if nothing's shorted and everything looks fine, then we'll go ahead and plug it into the drive. I won't have this plugged in, but we'll probably throw the scope on there and make sure that we see this guy like turning on and off, trying to actually fire the MOSFETs. And if that looks good, then we'll go ahead and plug them all in and hook up the test motor and see if it works. So the next video will probably be the scope hooked up to the output here, and we should see some nice little sinusoidal looking pulse widths as I have it not actually spin any motor, just kind of going real slow. But yeah, we'll see what happens. Anyways, thanks for watching. Bye.